Hi, today I will explain about KNearest Neighbor. I am currently working as assistant professor in BITS Pilani, Dubai campus. These are the topics which are going to be covered in this presentation: understanding of K-nearest method, and what is the impact of K on the classification that is going to be discussed, similarity measures, and K-nearest neighbor algorithm, lazy learner versus eager learner is discussed, appropriate use of K-nearest neighbor, and numerical exam is elaborated, and finally some questions on K-nearest neighbor and the conclusion. K-nearest neighbor works on the basis of majority voting. Consider there are two classes, one is of brown and another one is of green. Let us consider a unknown point occurs, and if k value is 1 and it is closer to brown sample, then it is considered as it belongs to brown class. On the other hand, if we consider k value as 3, then majority will be green samples, and therefore black will be treated as a green samples point in the green samples. How the K-nearest neighbor classifier works. Let's consider two classes. One is A and another one is B, and we have given a unknown sample as shown in the on the diagram as question mark. What are the requirement in order to perform K-nearest neighbor? A set of stored records, something like A, B, and there are so many samples in our data set. We usually utilized a distance measurement method technique, something like Euclidean distance, or could be other technique can also be used, and value of k, that is indicating nearest neighbor, that is also used in this method. The steps for k nearest goes like this. First, the unknown record is given. We determine the distance between the unknown sample and all the records of the dataset, and we identify k nearest neighbor. We use the majority voting technique in order to decide among the k nearest neighbor which one is should be taken as the class label for the unknown sample. For this particular example, we can see that the majority among these k neighbors is B. Therefore, the unknown sample should be classified as sample B. We decide upon the nearest neighbor. Consider an example. This is a beautiful example illustrating the impact of nearest neighbor on the classification process. There are two classes, one is minus, another one is plus, and there is an unknown sample as shown here. If we consider k equals to 1, therefore x is very close to minus, and therefore unknown sample is treated as it belongs to minus. Now suppose we increase k value to 2. That means there are two neighbors which are closer to x. Now there are two samples, one belongs to minus, another one belongs to plus. Now there is a confusion. How could we resolve this particular confusion? If we increase the number of k nearest values, then it can be resolved. Now if three nearest neighbors are considered around x, in this case there is one minus and there are two pluses. As the majority goes to pluses, the x is treated that it belongs to plus. This is how the impact of k value on the classification. Nearest neighbor classification is greatly affected. How do you choose k? If it is chosen very small, it is sensitive to the noise. If it is you choose k value as too large, it also impact on the classification process by considering many points which are not relevant to the unknown sample. Therefore, choosing the k value is very sensitive and important to achieve better classification rate. K-nearest neighbor classification technique utilizes a similarity technique such as Euclidean distance. The Euclidean distance is used to measure the distance between unknown samples and known sample of the set. K-nearest neighbors are also called as lazy learner. As the property of the lazy learners, they do not develop any model explicitly. On the other hand, there are some eager learners such as decision tree, neural network. They do make the model and utilize this model to perform the prediction. But lazy learner are don't provide any of the model until there is a unknown sample appears. They are also called as instance based learning, and they delay the process of processing any data until new instance to be classified. There are typical approaches in instance based learning: k-nearest neighbor approach, locally weight regression, case based reasoning. Lazy learner versus eager learner. There are lazy learners such as KNearest Neighbor. They simply store the data and the training data until an unknown sample appears. On the other hand, eager learner such as decision tree or neural network, they process the data and build the classification model, and eventually they use this model to perform the classification. The lazy learner training time, however, is much faster. On the other hand, they take a lot of time during the prediction time. On the other hand, when we're comparing to the accuracy, lazy learner are more or less same to the eager learner, but they may provide many local linear function to form the global approximation of the target function. But eager learner usually prepare a single hypothesis that covers the entire instance space. KNearest Neighbor could also be used for to perform prediction of continuous values. How do we do that? We can take the average of all the sample which are near to the unknown sample and treat the value of the unknown sample as the average whatever comes out from the group of values. The another modification in this process is to utilize the weightage to be given to the distance, because many of the samples are near to the unknown sample and there are some sample which are far away. The nearest sample should be given high weightage and the far away sample should be given less weightage when we are giving the majority voting. Therefore, the distance should be utilized as a inversely proportional when we are computing majority voting. So when to consider k-nearest neighbor? K-nearest neighbor can be considered when the points in the data set are real value domain and the features are in small in number, such as 20 features typically normalized, and there is a lot of data training, then k-nearest neighbor is a good candidate. What are the advantages of using k-nearest neighbor? They are fast in training, but they are slow when they are performing the prediction. That is a disadvantage. They can able to learn complex target functions and they do not lose any information while performing the classification or going through developing any model of classification. What are the disadvantage? As I stated, they are slow at query time and they can easily fooled by irrelevant feature. Okay, they are affected by the noise in other sense. Let's consider a numerical example. We have given two class problem. There are four samples. One class is of bad samples and another one is of good sample. We have also been given an unknown sample. What is that? Here it goes, and it also has the same number of attribute or features you can observe from the table, and what we need to decide is what is its class. So what is the first step in order to perform the k-nearest neighbor? Compute the distance. We compute the distance between the given sample and the unknown sample. These are the distances, and we utilize these distances to identify what are the nearest neighbor to the unknown sample. Here we go, identify nearest neighbor. So is it first sample belongs to the nearest neighbor? Yes, because this is the one of the smallest distance between the unknown sample and the given data set. And is this one, the second is a sample which belongs to nearest neighbor? No, because this is has a maximum distance, so therefore it is not belonging to the nearest neighbor group. 3 and 3.6 are quite lesser in distance, so they are also in the nearest neighbor group. Final comes the prediction of unknown sample. How do we perform the prediction? Based on the majority vote. Here we can see that majority goes to good class. Therefore, the unknown sample is treated as good class. What are the questions related to this topic of K-nearest neighbor? First one is, what are the differences between lazy learner and eager learner is one of the important question. And what is the impact of K on nearest neighbor classifier? Does it improve better? What should be the optimum value? These are the important topic of consideration. How K nearest neighbor classification can also be used as a regression technique where continuous value can be predicted. How computation value is affected with the change in feature dimension. These are some of the questions on K nearest neighbor class. On conclusion, K-nearest neighbor is an instance-based learning, and they delay the process of carrying out the classification until a sample appears. The K-nearest neighbor are also affected by value of K, therefore it makes sense to work on value of K before K-nearest neighbor classification technique is applied for any given data set. They are also lazy learner, hence they slow at query time. K nearest neighbor can learn any complex function. Thank you for listening to this presentation. I hope you found some of the insight on K nearest neighbor classification technique.